There is a number that people claim is hidden in the Great Pyramid, in the Parthenon, in the Mona Lisa, and in your own face. It's called the golden ratio, and most of what you've heard about it is wrong. But underneath the myth is a real number, 1.618, that genuinely does show up in nature, in mathematics, and even in the strange physics of crystals that shouldn't exist. This is the real story of the golden ratio, where it actually came from, why a Renaissance friar called it divine, who invented the legend, and what's actually true. The first written definition comes from Euclid's Elements, around 300 BC. He called it the extreme and mean ratio. Cut a line so the whole is to the longer part as the longer part is to the shorter. Euclid wasn't chasing beauty. He needed that exact ratio to construct a regular pentagon, using only a compass and a straight edge. Draw a five-pointed star, a pentagram, inside a regular pentagon. Every single diagonal you draw is longer than the side next to it by exactly the same factor, the golden ratio. Draw a smaller pentagon in the center of that star, then a smaller pentagram inside that one, forever. The Pythagoreans found this so uncanny they reportedly used the pentagram as a secret society symbol. In 1202, Leonardo of Pisa, later nicknamed Fibonacci, published a book called Liber Abaci. Buried inside was a thought experiment about breeding rabbits that produced a sequence: 1, 1, 2, 3, 5, 8, 13, 21. Divide each number by the one before it, and the answers get closer and closer to 1.618. Two completely different problems, one from Greek geometry and one from medieval rabbits, land on the exact same number. For most of history, this ratio didn't have a catchy name. In 1509, the friar Luca Pacioli published an entire book about it called De Divina Proportion, illustrated with diagrams by his friend Leonardo da Vinci. The term golden section only appears around 1835, coined by the German mathematician Martin Ohm. For over 2,000 years, nobody had called it golden at all. The Greek letter phi wasn't attached to it until 1909, when the American mathematician Mark Barr proposed it, reportedly in honor of the sculptor Phidias. Algebraically, phi is almost eerily simple. Phi squared equals phi plus 1, and its reciprocal 1 divided by phi equals phi minus 1. No other number does that. Its continued fraction is an infinite string of ones, the simplest possible pattern, which mathematically makes phi the hardest number in existence to approximate with a fraction. It's sometimes called the most irrational number there is. Here's where the story goes off the rails. Since the 1800s, people have claimed the golden ratio was deliberately built into the Great Pyramid of Giza, the Parthenon in Athens, Notre Dame, and the Mona Lisa. Almost all of that traces back to one man, Adolf Zeissing, a German psychologist who in 1854 decided the golden ratio was the secret of natural beauty, then went looking for it everywhere until he found it. Historians have since shown his measurements were selectively drawn, and often just wrong. There is no surviving document from ancient Greece or Renaissance Florence that mentions designing anything around this ratio on purpose. But phi didn't need the myth. It shows up for real, just not where the legend says, and not because anything is beautiful. It shows up because of how living things grow. Look at the seeds in a sunflower's head, or the scales on a pinecone. Each new seed appears rotated about 137.5 degrees from the last one, an angle mathematicians call the golden angle. In 1979, the biologist Helmut Vogel modeled this precisely. That specific angle, derived directly from phi, packs the maximum number of seeds into a head with zero wasted gaps. Evolution found the optimal packing algorithm without knowing any mathematics at all. In 1982, the materials scientist Dan Schechman found crystals with a five-fold symmetry that textbooks said was mathematically forbidden. His own colleagues mocked him and asked him to leave his research group. He was right. These quasicrystals are real. Their atomic spacing is genuinely governed by the golden ratio. And in 2011, Schechman won the Nobel Prize in chemistry for a discovery everyone once told him was impossible. That same most irrational property is exactly why the sunflower angle works. Any angle that was a clean fraction of a circle would eventually line seeds up in overlapping rows. Phi is the one angle guaranteed never to repeat that way. Take any rectangle where the sides are in the golden ratio, slice off a square, and what's left is a smaller golden rectangle. Repeat that forever and the corners trace a smooth spiral. That spiral gets compared constantly to a nautilus shell. Real measurements of actual nautilus shells show their spiral ratio varies, and usually isn't phi at all. Another beautiful coincidence that isn't quite what it's sold as. Financial traders use something called Fibonacci retracement levels to predict stock prices. There's no proven mechanism connecting phi to markets. Most economists think it works only because enough traders believe it and act on it together. Engineers, on the other hand, use the real golden angle on purpose today, spacing solar panels and satellite antenna arrays using the exact same packing math the sunflower stumbled onto first. And phi is the only positive number where subtracting one gives you its own reciprocal. Ask a calculator for the square root of 1 plus the square root of 1 plus the square root of 1 forever, and it converges on phi as well. The golden ratio's real legacy was never a secret code hidden in ancient monuments. That part was invented in the 1800s and repeated ever since because it makes a better story than the truth. The actual legacy is stranger and better. A number this simple connects a Greek pentagon, a medieval rabbit problem, a sunflower seed head, and a Nobel Prize-winning crystal nobody thought could exist. Every video on this channel is built around one idea, one pivotal moment that quietly changed everything, explained clearly in under 15 minutes. If that's useful to you, subscribing means you don't miss the next one, and there's always a next one. And if this video changed how you think about something, even a little, hitting like is what tells YouTube to show it to someone else who needs it too. If this one was worth your time, there's another turning point video waiting for you right there.